so I'm going to turn it over to Tim now, and he's going to talk to us about building a 2-meter J-pole. So he's the expert. Ask him all the questions.
Oh, I'm not really the expert, but I'll try. But here, I was at a 5K, 10K race, helping out with communication. Larry was there too. Larry was bicycle mobile, and he had his bike, and he had a safety flag on a fiberglass stick, and tied to that fiberglass stick was something like this. Okay, and well, I'm standing there with my HT and my rubber ducky, and I'm thinking, you know, this probably works a whole lot better than this. I'm gonna make one. So about 10 years later, I finally got around to thinking about it, and then I set forth to actually make one. And I set out with the attitude of, you know, I really don't care about antenna theory. I don't care what this is. I don't care how it works. I want to make one, and I want it to work. And I want it to work the first time. I don't want to have to do any pruning, tuning, cutting, slicing, any of that stuff. So give me the dimensions, give me the plan, give me the formula. I want it to work. I want to be done with it. Whoa, bad attitude. Because, well, really, the more you know, the more you know. And if you understand what this is and how it works, if it doesn't work, you got a chance of figuring out why and fixing it. So, yeah, let's make one, but let's also figure out what it is and how it works. Because when you get into discussions with your ham buddies and you know a little bit more about it, you've got the upper hand in the conversation. Okay. Well, yeah, I set forth to just make one, and I looked at the ARRL Amateur's Handbook. I couldn't find anything. I looked through miles and piles of files of stuff that I had, a lot of plans for HF antennas, but I couldn't find anything for the 2-meter J-pole. So I went to the internet, and I found all kinds of goodies. Well, from all kinds of websites, all kinds of radio club sites, and here's what I found. They say that it's a half wave that's fed by a quarter wave matching section. Okay, so this bottom part here is a match, and the top part is the business end, and it's a half wave. Okay, that's interesting to know. Also, it's a balanced feed point antenna, but it's typically fed with coax. You can do that? I guess so. And then the velocity factor of the cable affects the dimensions. Well, that's probably why all these websites that I went to had different plans with different numbers, different dimensions. The velocity factor? Well, okay, I guess so. One of the most encouraging things I found on one of the ham radio club websites is this, that there was a guy in the club who made one of these, and it worked. And we copied his work, we copied his design, used the same materials, same dimensions. We all got together at a radio club, we all made one, and we all went home with a working antenna. Oh man, that's great. That is just fabulous. So yeah, you can do it. I did. But let's take a look at some stuff so that we know what we're dealing with. I figured the best way of going about this is take a look at stuff that we already know and see how it applies to what we're doing. So one of our favorite friends is the dipole. Our friends on HF radio just love them. It's a balanced feed point antenna. Let's see, the feed point impedance, yeah, is 73 ohms. That's right. And at the feed point, okay, you got a quarter wave this way, a quarter wave that way, total of a half wavelength. Fed at the center, that's the lowest impedance. The current is the highest, and it falls off to 0 at the ends, and then the voltage starts to increase, and it's the highest at the ends. Okay, now let's take this concept. Let's take this feed line and kind of like move it that way. It's like what, off-center fed dipoles, the Wyndham to some extent, the end-fed ZEP, end-fed verticals. It's kind of the same thing. So if we push this feed line over here, all of a sudden we got like a real high impedance, and yeah, we got to match the high impedance of that feed point to the low, fairly low impedance of our feed line and our transmitter output. Now our friends on HF radio can do this with any number of capacitors, coils, transformers. Sometimes these are referred to as lumped elements. Who would refer to a capacitor as a lumped element? Probably someone who discovers or who knows what distributed elements are, someone who understands feed lines, microstrip, things of that sort. And let's just take a look at what we need to know. Some of you might remember the rules of shorted and open quarter wave sections. First of all, take a look at the perfect scenario. We've got an antenna, a feed line, and a transmitter, all the same impedance. The transmitter output, the feed line impedance, the antenna feed point, all the same value. Now, if I had a magic antenna feed line current measuring instrument, I could go anywhere along this line, I would get the same number. Same thing with my voltage measuring instrument, could go anywhere along that feed line, get the same number. Okay, now what I'm going to do, slice off the antenna. Instead of a load, I've got an open. Now, at the open circuit, just from a DC standpoint, an open circuit is not going to draw any current, but it's going to have high voltage. And that's what you see here. With an open circuit, right at that open, the current is 0, and the voltage is some real high value. Now, let's take this magic feed line current measuring instrument and start traveling this way along the feed line. We see it start to increase. And at the same time, we see our voltage start to decrease. When we get a quarter wavelength away, the situation reverses. We have like very low voltage and very high current. And then we go another half wavelength, and the situation is the same. Now, it's those two R's that you have to keep in mind. This is kind of hard to remember, but for open and shorted feed lines, what you have happening reverses every quarter wave, and it repeats every half wave. Okay, remember that. Reverses every quarter, repeats every half. Now let's take a look at the other scenario where we have a short circuit instead of an open circuit. Okay, now again, from a DC point of view, if you put a short circuit across your power supply or a short circuit across your battery, it's probably going to draw a lot of current. And that's what happens here with the short. Again, our magic feed line current measuring instrument, if we look at that, yeah, it's a real high value. And as we travel back along the feed line, it starts to decrease. Then it gets to 0 at the quarter wave, and then it repeats at half wave. Remember that? Reverses every quarter wave, repeats every half wave. Okay, see, I forget that too. All right, let's take a look at this short circuit scenario again, and just this quarter wave section here. Okay, let's zoom in on that, take a snapshot of it. Let's just turn it around and look at it like this. Okay, so here we are. We've got 0 ohms impedance at the short, and as we travel this way, the impedance starts to increase somewhere, hopefully a pretty high value, 3,000, 4,000, 5,000 ohms, hopefully the impedance of our half wave. And somewhere between 0 and 5,000, we should be able to find 50. And that's where we want to attach our feed line. Whoa, okay. That's it. That's all you need to know, really. But I was very interested to find out that, yeah, that's what this is. This is a half wave right here, and it's fed by an approximate quarter wavelength feed point. Okay, so let's make one. This requires a little bit of talent with your hands and your soldering iron and your various cutting instruments. Here are the dimensions that I found. I redrew this and kind of repeated it here. I like to start from the bottom end and work my way up. The total length is, what is it, 52 inches here? Okay, so then you spool off 52 inches of wire from your reel. Oh no, you better make it a little bit more than 52 inches, because the first thing you have to do is make the short circuit, connect the two ends together, and if you do that, you bend the wire, okay, you lose like half an inch right there. So when you're spooling it off or cutting it off, make sure you get a little bit more than 52 inches, or if you happen to be the owner of the spool, you can just start at this end and work your way down. So yeah, that's what I did. Slice it off, bend it over, solder it up, like so. Okay, the next thing, okay, this is the tricky part, because this is where you attach your coax, your feed point. What you want to do is poke away just enough so that you can get the center lead of your RG-174 around one side, and then the twisted up ground around the other side. It's, it takes a little practice, and maybe you might need a little bit of practice, but it's like you get an X-Acto knife and you put a slice here, put a slice here, then put a slice here, put a slice there, then kind of go around, then go to the other side, put a slice here, put a slice there, put a slice, put a slice. The idea is to carve away just enough so you can get that wire around there, in there, and solder it. It's a lot easier to try to do this with RG-174 than it is with like RG-8 or fat coax with fat wires. So yeah, there we are. Same thing. Oh, here's the feed point. 1 inch and 5/8 from the bottom. And that's going to change a little bit depending on what kind of coax you have, or what kind of twin lead you have, and the velocity factor. So, keep that in mind. Same thing. Same thing here. This is a dimension that you have to be kind of careful with also. Yeah, 16 3/4 inch from the bottom. Make a cut. Okay. This is the important dimension here. When you make your cut here, it says that the matching section stops here and the radiator section starts. So that's kind of an important thing. What's really not real critical is the length. I have, a 1/4 inch slice marked right there. You just have to have enough so that it's separated. And then you can measure 52 inches from where you've soldered and where you go to the top. Oh, okay. Yeah, don't forget to poke a hole in the other end, tie a rope to it, and put a little weight on if you want, because you can, shoot this up into a tree and hoist it up, or, tie it to the fiberglass stick on your bicycle safety flag. So, yeah, don't forget about that. Now, the hardest part of this whole thing, that's it.
Can I back you up once?
Oh, sure.
I got a question for you. All right, so I get the part where you measure up 16 3/4 inches and then you cut it. Is the unconnected part above that important? Or say, for example, what if I stripped that piece of wire out? Would it affect the performance?
Oh, yeah, that's a very good question. I don't exactly know the answer to it. Basically, the show is over with, and I can ask questions, but that's something that someone is going to ask, is what about this other conductor here? Some people say, yeah, pull it out, cut it away, prune it away. And some people say, yeah, all you really need is like this part, and you can stick any wire or any kind of cable you want, or any other kind of radiator to this part. Yeah, I don't really know. On mine, I left it there. There's another group of people who say, well, why didn't you connect it up here? Because then you've got half a wavelength here, you've got another half length here. That's called the Slim Jim. And some people say it works better, some people say it doesn't. Well, the thing is that when you do this, this changes. The feed point, the quarter wave matching section. So yeah, the Slim Jim with the other end connected is kind of a whole different animal. But you're right, I really don't know what happens if you take this out. I was kind of thinking that you could, like connect it over here and then connect it up here, and then you'd have like the two of them in parallel. It would be the same thing as a wider piece of wire. You'd get, better bandwidth, better SWR on the fringes. So,
Well,
yeah, I don't know.
I know if you took the wire out, that piece of wire out, the velocity factor of the remaining piece would change somewhat. I don't know by how much, but.
Oh, it probably does. That's and that's a very good thing to note. But the last thing I wanted to mention is that the hardest part of this whole thing is right here at the other end. If you have an HT, you probably have an SMA connector. If you've never done one of these before, it does take a little bit of talent. And I like the ones that you can take apart and redo and reuse. And also, if you screw it up, you can take it apart and maybe try it again. These are like 10 or 15 bucks from DigiKey. But there you go. I mean, it's great. I've done this, a couple of times, where you take this, you put it on your HT, and hoist this up in a tree, and you can hear stuff and talk to people. Where's the nearest repeater? Well, we can try that. We can try that later. But anyway, that's it. I'm done. Questions? And okay, you've got a real good question right there. Is what about this other end? What is the Slim Jim? That's a variation of the J-pole. There's another one, of course. Someone is going to say, wait a minute, you said this was a balanced feed point antenna and you're feeding it with coax? You can't do that. That's against the rules. That's not going to work. Well, yeah, it does work. But when you get reflected power, it's going to come back on the outside shield of your cable. It's going to get into your rig and give you RFing and all kinds of things like that when you have a high SWR. And it says, well, you're right. The reflected power is going to come back on the outside of the cable, and it could screw things up. And if you have a high SWR, yeah, it's going to be a problem. But if you don't have a high SWR, it's not going to be a problem. Your HT can probably handle a little bit of RF coming back on the coax. There's a handful of other things that you, yes?
If you wanted to like run your mobile portable, you know, a park or something, is there any power handling limit?
Well,
Like, you know, if you have
yeah.
65 watt 2-meter mobile.
Yeah,
put it on the tree, without setting the tree on fire?
The HT puts out 2 watts, and I think this is more than enough cable thickness for 2 watts. But I've heard people say that you can use RG58 coax, and you can run 50 watts
50?
through something like
Okay.
this
So
with,
you could run a mobile.
with twin lead. Yeah, so you could hook up your mobile rig, you could run 35 watts through it without too much of a problem. There's another question that could come up. Someone could say, well, you've got 300 ohm twin lead here. What about 450 ohm ladder line? Can't you make a J-pole out of 450 ohm ladder line too? Yeah, that's another different recipe, different plan, different variations. Another article I saw described some advantage of using 300 ohm line over the big wide 450 ohm ladder line. There's something about that the 300 ohm twin lead works better than the 450 ohm. That's another thing that your ham buddies can be talking about on the repeater, and you can discuss that and talk about the people who used 450 ohm ladder line. Oh, there's another one. Well, it's not a perfectly circular radiation pattern. It's not a perfect, well, no, it's not. Because you're feeding a balanced feed point antenna with unbalanced line. And the coax, when it comes off like this, it acts somewhat as a counterpoise. And it does affect the radiation pattern a little bit. And then, of course, people ask, well, when you make it, does this have to come straight out, or can you bend it a little bit? Yeah, you can bend it a little bit. I put some silicone here so that it doesn't bend too much, and so that it flexes and takes up some of the strain. But I think the idea is to keep it, at least the diameter of the twin lead, keep it straight for at least the diameter of the twin lead before you bend it. Okay, there were a couple other things that I was going to throw out here, but I can't think of what they are. You're going to come up with
What's the tolerance on that feed point for the 50 ohms? I mean, how accurate does it have to be? Are we like is it 1/8 of an inch, a 1/16 of an inch? I mean, obviously it's going to vary with the type of material it gets made out of, right? What kind of coax, but I mean twin lead. But how much play do you have with that dimension?
That's another very good question that I really don't have a very good answer for. Yeah, I think you should try to get it as close to 1 inch 5/8. The idea here is that you want to find the 50 ohm point, and going this way it drops, going this way it increases. I think I just tried to follow the recipe as best as I could. I have a write-up, an article that describes how to figure that out using the Smith chart, and you got to have a Smith chart. You've got to know the velocity factor of your cable, and then you figure out exactly where it is in terms of like a 90-degree angle, and then it gets really complicated. And I hope you're going to thank me that I haven't brought that and tried to present it here, because it's a little bit over my head. You have to understand Smith charts, but that's what's happening here at the bottom end, and that is kind of scary, because from like the DC point of view, this is a short circuit. I've got this much feed line before I'm running my rig into a short circuit. Do I really want to do that? Well, yeah, it works. It actually works.
If we had an antenna analyzer, we could hack up your antenna and find out all those.
Yes, here's another thing. If you had an antenna analyzer and you hooked this up to the other end, you might get some funny indications, because again, you're feeding a balanced feed point with an unbalanced feed line, and that causes some weird things to happen with antenna analyzers. Another, yeah, Mert.
You might be able to improve that balance to unbalance a little bit if you put a ferrite bead or two on there. Or-
Yes.
Or like, sometimes they tell you to
Oh,
coil
yeah,
up the feed line a little bit.
wrap it up a couple
Yeah,
times. Yeah,
yeah.
you can do that
Yeah.
too. I haven't tried that. I just had real good luck, just the way it is
I
here.
think the beads would be kinda neat.
And I thought about using the coaxial balun, you know, a half wave, you know, that would probably work too. Oh, there's all kinds of things we could try here. Oh, I just thought of something. There's another thing. Your ham buddies will say, well, the advantage of this is it's a no ground antenna. You don't need like the radials for a vertical. They say, yeah, it's a no ground antenna, but you still have to ground it. Well, you know, that's a problem, because take a look here. You see where this little arrow is? That is theoretically the 0 voltage point of this antenna. And if you're going to ground it, that's where you ground it. But wait a minute, no, we're feeding this with coax, and the outside of the coax is ground. So if you've got the outside of the coax grounded, and you got that point grounded too, you're going to run into a problem. And I think a lot of people have run into a problem because they try to do that. And then their SWR is even worse, it goes up even higher. Antenna performance is even worse. If you're going to do this, okay, if you're going to ground it, that's where to ground it, right here. And then make sure that you do have a balun or something that gets this ground away from that point.
Which side is your coax shield going to on that one?
Okay, that's another good question, because again, we're feeding a balanced feed point antenna with unbalanced cable. Supposedly, it doesn't matter. But when you get down to, oops, other way.
One way might work better than the other.
Yeah, when you get around to actually doing it, you know, it's another thing your ham buddies are gonna say. It doesn't work? Well, just switch the coax around. And yeah, that might make a little bit of difference. In one of the articles that I ran across, it was stated that the center lead of the coax goes to this side where you have the radiator, and then the ground side goes to the short end. That's how this one is made. And most of the diagrams, pictures, recipes that I found show the ground going to the short quarter wave side. And this other write-up that I found, someone describes a reason why that is somewhat preferable. It works out a little bit better doing it this way than that way. Anything else? Yes, Bob?
Did you, do any kind of, did you put any kind of a meter, SWR meter, or anything else, or did you just follow the recipe and found that it worked well?
Well, I followed the recipe and found that it worked well. The reflected power on this is it works better on the low end of the band, because I did make it a little long and I didn't cut it. So, yeah, it's what was, I forget what it was. See, the problem is that your SWR meter has got, you know, PL259s or Ns, and this is an SMA, and how many adapters would you have to use before you get to that? So yeah, I did it, I looked at it and said, whoa, you know, that reflected needle, that does move a little bit. So yeah, it's not perfect, but it's good enough. And it's too long. I haven't trimmed it or tuned it yet. There you go. Anything else? Whoa. All right. Thanks. Yeah. So here's the thing: is if you wanna make one, this is some twin lead that I got from Radio Shack. I've got a bunch of it here. RG 174 skinny 1/8 inch coax. I don't know what this is. SMA connectors. Boy, I wish I was, you know, rich and famous again, and I'd buy a couple dozen of these things and bring them all here, and we could all make them. Yeah, like I say, this is the expensive part. This is, and it's the hardest part of making the antenna. So there you go. Leon's got a bunch of twin lead here also.
So if somebody wants to stick around and make one, they'll stick around also.
Possibly.
Or you need some extra. Pardon?
Do that in November.
Yeah.
Yeah, I think it'd be kind of a fun thing, and if someone did want to order up a couple dozen of these SMA connectors, I think they're like $15 now. They were $10 a couple years ago.
All right, well, thanks, Tim.
Price goes up. All right. There you go.
Oh, any other thoughts? Questions? Thanks for showing up. Remember to grab a cold drink for the road.